Hello everyone, I'm Tassallah Amina Abdullahi, a second-year computer science master student at the University of Cape Town. I'm here to present my research poster titled Diarrhoea Outbreak Prediction Using Climate Change. Diarrhoea is a leading cause of morbidity on the global scale, and is also a leading cause of death in South Africa for individuals of all ages. Southern Africa is a climate hotspot and will experience frequency and magnitude of extreme events like drought and heat waves. These events have the potential to increase infectious diseases like diarrhea diseases. Currently, possible threat of diarrhea is only identified when there is an increase in the rate of hospitalizations, which means that an outbreak is only identified when there is an epidemic. Using machine learning, we may be able to establish an early warning system for diarrhea outbreak in various provinces with respect to climate information. The aim of this thesis is to use climate variables to make focus about the possible number of diarrhea cases in the nine South African provinces. The objective is to detect which supervised machine learning technique is best when predicting an outbreak of diarrhea disease, given a range of data sets. So we've chosen convolutional neural network, long-short-term memory networks, and support vector machines for this thesis. So we got a 10-year data period of a period of 10 years on the daily sales record of loperamide, which is an anti-diarrhea medication. And we also got a daily record of climate factors of interest in 9 provinces. So we use the daily sales record as a proxy to identify the number of cases of diarrhea cases in a specific province. So if there are 10 sales, we will just mean they're like 10 cases. So our methodology to determine the best performing algorithm, we compare the root mean square error from the predictions made by the 3 algorithms in different scenarios, which were broken down into experiments. In experiment 1, we used the original data we got, and we used grid search tuning to tune the parameters of our 3 machine learning algorithms. In experiment 2, we realized that, or studies showed that machine learning algorithm perform better when there is a large amount of data set. So we augmented the data we had already with synthetic data, which was generated by GANs, and we also maintained the grid search parameter tuning. In experiment 3, we used evolutionary strategy to tune the parameters instead of grid search, and we still maintain the augmented data set in experiment 2. So in all these 3 experiments, the results we got are as follows. In experiment 1, we noticed that the CNN performed best. From the graph, the lowest RMSEs indicate better performance. So CNN performed best, followed by LSTM and then SVM. In experiment 2, we augmented the data in 2 ways, upward and downward way. That's why you can see upward and downward in the graph here, upward and downward. So either way, the augmented data improved the performance of all 3 ML models, you can see. And then LSTM performed best here. Unlike CNN, its performance was competing against SVM in some provinces. So we went further to carry out experiment 3 with a different parameter tuning, which I explained earlier, REVAC, and here CNN's performance improved drastically. And then here still LSTM outperformed the others. So we concluded that the 3 machine learning methods were appropriate because they all yielded this similar and low root mean square error. However, as we saw in the results, the errors varied. CNN performed best in experiment 1, and LSTM performed better in experiment 2 and 3. Overall, the deep learning models outperformed in all experiments. In addition, the use of augmented data improved the performance of all our models. So if you have any questions, you can send me an email. Thank you. Bye.